Kai scored 24 points in a basketball game, shooting a total of 10 2-point and 3-point shots. How many of each shot did he make in the game? Let X be the number of 2-point shots and let Y be the number of 3-point shots. We can use the following set of linear equations to determine the number of 2-point shots and 3-point shots made. This is an example of a system of linear equations. A system of linear equations is a set of two or more equations with the same variables taken as one or solved simultaneously. The solution set of a system of linear equations is the set of all ordered pairs that make all equations in the system true. There are three types of system of linear equations. A system with no solution involves parallel lines that will never intersect with each other. This is called an inconsistent system. A system with one solution intersects one time. This is called a consistent independent system. And a system with infinitely many solutions is two identical or overlapping lines that intersect everywhere. This is called a consistent dependent system. Let us take a look at example 1. We have two linear equations, one of which is already in slope-intercept form. We rewrite the second linear equation in slope-intercept form. We divide both sides of the equation by 4 and end up with y equals 5/4 x minus 3. Notice that the two linear equations have the same slope. This means they are parallel. We know that parallel lines would never intersect. Therefore, this system of linear equations will have no solution. We can verify this graphically. The red line is for the equation y equals 5/4 x plus 3. The blue line is for the equation y equals 5/4 x minus 3. Let us consider example 2. We have two linear equations in slope-intercept form. We go ahead and graph each line. The red line is that of the equation y equals 2x plus 1. The blue line is that of the equation y equals negative 3/2 x plus 8. The point of intersection, 2, 5, is our one and only solution to the system of linear equation. We can verify this algebraically. We substitute the x and y coordinates of the point 2, 5 in our system of linear equation to check if both will be satisfied. So, for the first linear equation, we would have the following solution. Likewise, for the second linear equation, we would have the following solution. Note that 2, 5 is the only solution and is the only point that will work for both linear equation. Finally, let us move on to example 3. We have another system of linear equations. The first linear equation is in slope-intercept form, while the second linear equation is not. If we rewrite the second linear equation in slope-intercept form, we end up with an equation that is exactly the same as the first linear equation. This means the two linear equations are identical. If we graph each line, the second line is going to be right on top of the first line. Hence, every single point would be a solution. Moreover, since lines have infinite number of points, this system of linear equations would have an infinite number of possible solutions.